Hello everyone, welcome back. As requested by a few users, I put together a video how I made an external 10S 5P battery pack for the Hover 1 Pioneer. First off, I do apologize for taking so long to put this video together. I've been extremely busy with work and family that I have not been able to sit down and work on this. Anyhow, I'm excited that this video is finally completed as it's been on hold for a while. So before we get started, just keep in mind that there's many ways and better procedure to making an external battery pack, but what I'm doing is what works for me. As always, working with lithium battery can be dangerous, so make sure you have the proper knowledge of handling and working with lithium battery. With that being said, let's build this battery pack. For this project, I'm going to build a 10 series 5 parallel battery pack using these 50 LG cells I got off Aliexpress. You can use any of the same type of 18650 batteries and build any number of battery in parallel that you want. The items I'll be using is the 10 series 36V BMS, a Sunco 737G spot welder, some nickel plated strips, a fuse and fuse holder, a female charging port connector, a Diesel bike bag, a soldering iron, a hot glue, zip tie, and some wires. Safety is always the #1 priority, so don't forget the safety glasses and gloves. First thing I'm going to do is hot glue the battery together. This will help hold the battery while I'm spot welding them together. So all I'm doing here is just hot gluing 5 batteries together in parallel. So for example, if you're doing a 10S 3P battery pack, you'll be gluing 3 batteries together instead of 5. I'll keep doing this until I get 10 set. Next step, we will need to spot weld the nickel plate onto the batteries. I have cut up the nickel plated nicely so that there's no sharp corner. Since I don't have a spot welding pan and my welding needle only extends so far, I start with 4 batteries that glued together. I will be gluing the set of batteries opposite to one another, side to side as you can see here. It will be like this for the rest of the batteries. If you have a spot welding pan, you can glue all 10 set of batteries together, making the spot welding process easier. I will start welding the positive end to the negative end like this. I will refer to this side as side A, so it will be easier for you to follow. The next nickel plate will go right next to the first one, just like this. Once we are finished, we will flip the battery to the second side, which I will refer to as side B. This time we will weld the center connection together. You must be very careful not to touch the nickel plate to the other battery, as they may short the battery and cause a nasty spark. After finish welding the center connection, we will then hot glue another series of battery onto the battery pack, just like this. On side B, we will continue to weld the 4th nickel plate onto the battery pack. we will glue the next series onto the battery pack. On side A, we will spot weld the 5th nickel plate. You will continue to repeat this until you get 10 series of battery together. Once you get to the end, you will weld the 2 strips of nickel plate to both ends, like you see here. Let's look at the BMS here. This one here is made for a 10S 36V battery pack. It comes with these balance wires that will go straight into the BMS like so. To get the BMS ready, you will solder some wires to the BMS. The BMS does not come with these wires, so you have to provide them yourself. Instead of buying these wires, I used a wire from some AC power cable I have laying around. I figured these should be able to handle the power load from the battery pack. The first wire will be for the negative of the battery. The second wire here will be the negative cable that connects to the negative of the scooter battery. The third wire will be the negative from the charging cable. I went ahead and spot weld the negative cable to the negative end of the battery and decided to use the zip tie to hold all the battery together. Here you will see me welding all the balance wires onto the battery beginning from the black negative wire. These wires repeatedly go side to side until you reach the end of the battery pack, which is the positive end. So let me go ahead and give you guys a closer look and a better clarification of how I weld the battery pack together. We have the BMS down here, but first let me explain to you how I have the balance wires connected. As you can see here, I have the black wire connected to the negative end of the battery pack, which I specified before as side B. Going from the black cable, the red wire next to it will be connected to the opposite end of the battery pack on the negative here, which is side A. The next wire in line will go on side B of the battery pack like this. So all the balance wire will go in this order and be connected zigzag like this across the battery pack until you get to the last wire. Here we have the fourth wire. It will go on side A. The fifth balance wire, it will go right there. The sixth balance wire, it will go right there. The seventh will go right there. The 8 will go across again right there. The 9th wire will be right there. The 10th wire will go on the other end right there. Finally, the last wire, it will go on the positive end of the battery pack like this. And that's all there is to connecting these balance wires. Now let's take a closer look at the BMS. Going for the heat sensor. The heat sensor will prevent the BMS from sending power if the battery pack gets too hot. I went ahead and just hot glue it onto the battery pack. Next, we have the negative wire to the charging port that will be soldered right there. The positive cable of the charging port, however, will be connected to the positive end of the battery pack. I just went ahead and wired it along with this white cable, which will be connected to the positive end of the scooter internal battery pack. Now let's look at this wire here. This is a negative wire that will be connected to the negative end of the scooter internal battery pack. Now we have the last wire. This wire just goes on the negative end of the battery pack. So that's all there is to wiring your battery pack. After you finish with the spot welding and soldering, you can plug it into the BMS and check for the voltage. With a fully charged battery, you will get somewhere around 42 volts. The normal way to secure and protect your battery is to use heat shrink over it. The heat shrink I ordered has not arrived yet, so I went ahead and protect the battery pack with some thick cardstock paper. Not the cleanest and safest way to secure your battery pack, but this will do for now until my heat shrink comes in. So I went ahead and put the battery pack into the bag. The bag's not too big or too small, and it fits the battery pack perfectly. I also add some foam onto the bottom of the bag to help cushion the battery pack from all the bumps and vibration. Now let's go ahead and open up the scooter so we can parallel the external battery pack to the original battery pack. They sell some XT60Y splitter connector that you can use to parallel the two batteries together. But for this demonstration, I'm just going to carefully splice the wire and just tap the external battery pack onto the original. And again, I'll be using the wire I salvaged from the AC cord to connect onto the battery pack. In this step here, I'll be taking off this blue rubber seal, and with this blade, I will carefully make a cut to widen up the opening for the extra cable that will be running through here. So let's go ahead and tuck this cable through like so. I'll be wrapping the black cable to the negative end of the battery terminal and wrap it in electrical tape. Before I connect the positive wire, I'll be adding a fuse on here. This fuse will act as a safety kill switch from your external battery pack to the scooter if the electrical current is too high. After connecting the two wire, we will go ahead and tuck the wire in and put back the bottom cover. Before I connect the battery in parallel, I went ahead and charged both the scooter and battery pack so that they're about the same voltage. And once you're ready to install the battery pack, it's quick and simple. I have here two cables that are connected to the battery pack. In my case, black is for negative and white is for positive. And here we have the battery pack with two corresponding wires that we are going to connect. But before we do that, I'm going to insert this cable into the headphone opening of this bag so I can protect the connection and hide as much wire as I can. So we're going to go ahead and take the battery out so we have room to work with. So let's go ahead and insert the first cable carefully and use it to pull the second cable through it so we don't risk the two cables touching one another, as we do not want that to happen. Now let's put the battery pack back in the back and then connect the battery together in parallel. We'll go ahead and attach the two Velcro from the back onto the stem of the scooter. I went ahead and also took the extra measure to strap down this battery pack with this strap that I have laying around. Alright, so let's turn it on. It turns on normally, and with the numerous tests I did, I'm highly satisfied with the results. With the external battery connected, I'm able to get a top speed of about 19.5 miles per hour and a total range of up to 30 to 35 miles on a single charge. And the great thing about having this battery pack along with the stock battery is that the speed does not decrease as the battery starts to run out of juice. I'm able to maintain a speed of 15 miles per hour or more from full bar to 1 bar. With the stock battery alone, the scooter will lose power and the speed will decrease dramatically the moment the battery starts losing power. Adding this external battery has given me the peace of mind and confidence in the scooter's performance. After numerous successful tests, I rode this scooter to work multiple times and even taken it out on a 30-mile trip with zero problem whatsoever. I'm happy to say I've turned a scooter meant for leisure and last-minute commute to something that can really take you places. Besides the battery, the bag also looks good. Material made of good quality and is perfect size for a 10S5P battery pack. It sits firmly on the stem and the deck of the scooter and still gives you plenty of room to rest your feet. A bonus is the headphone port, which allows you to wire into it, giving it a cleaner look. At the end of the day, I could just bought a pre-made battery pack and slap it on, but I'm proud of what I made. With this belt, I learned a lot about lithium battery and battery pack, which will open up the door for more future projects. Other than that, if you enjoyed this video and found it helpful, don't forget to give it a thumbs up, let me know what you think in the comment below, and consider subscribing if you're new. Thank you so much for watching, I'll see you soon.